So the topic is, what does it take to be an expert at Python? And most of you guys might be using Python in your daily day-to-day life programming, or you might be familiar with it. Some guys might even have been using it for a lot of time. So maybe this topic won't make sense to some of you, but let's see what exactly I'm trying to cover in this topic. And so let's begin. Yeah. So the first question is, and the general question that's asked, but what is Python? Now we all know Python is a programming language. What's the big deal in that? Like, what exactly am I presenting? So actually, Python is more than that. It's a high-level object-oriented general purpose scripting language. So it's more than just a programming language. But again, as I discussed, most of you guys might actually be using Python and be really comfortable with it. So what new things am I going to tell you? Let's see what exactly am I going to tell you. And in the meantime, you could let me know in the chat section that how many guys or how many of you guys have been using Python or are actually familiar with it. So it would be, just like a survey for me as well. So the first thing that I want you to know is Python is bad at math. I know it's really a bold statement to make at the beginning of the presentation, because after all, we know computers are made for calculations. They could do huge scientific calculations. But I want you guys to try something. I actually want you to open your Python console, the IDE or whatever you, maybe VS Code or any environment that you actually use, and then just type in 0.1 plus 0.2 minus 0.3. That's it. I want you guys to type it if it's possible. You could always guess what's gonna be the answer, let's say. So you could also let me know in the chat section what you guys think would be the answer if I do this simple arithmetic. I'll be waiting for a response from someone. I'm audible to you guys, right?
Yeah, but we don't have right now actually setting up the Python console.
Yeah, it's fine.
I
So
did
you
not
could,
have it open.
yeah, maybe you could at least guess what. I don't actually want you guys to code it out, but maybe you could guess what the answer could be, because most probably it's gonna be zero, right? It's really simple. It looks really simple, but that's actually not the case. So let me actually try it for you guys. So I could say 0.1 plus 0.2 minus let's say 0.3, and I hope this environment works for it. So now you see that it doesn't actually give me zero, but it gives me this cryptic looking answer. It's 5.55 and something e to e then minus 17, right? Yeah, as Vimlesh said. So what could be the reason for it? If you actually look this number closely, that's how Python represents floating point numbers in the scientific form. So e minus 17 actually means 10 to the minus 17th power. So it's a really small number. ये बहुत एक छोटा सा number है, as I told you, but it's not really zero. And the point of Python or point of programming languages or computers is to give us precise answers, right? Now the reason for that is really simple. In case of Python or in most programming languages, actually, floating point calculations don't work, because the general problem is that whenever, let's say that you're trying to convert 0.1 into binary, 0.1 from decimal to binary, it's actually non-terminating decimal. And in case of Python, number is not actually represented, just in bits, but it is actually converted into a format, and it's more like a fraction or where the denominator is 2 power 55. So as I told you, in Python, the numbers are represented as ratios, where the denominator is always 2 power 55. You could also verify it using as integer ratio function in Python. So that's the first thing that I wanted to tell you. Maybe that's why you heard never, compare floating point equations, because computers just don't work that way. The second thing is, there's always an else. In case of Python, there's always gonna be an else statement you could add, because right now all we did is we added an else statement to if, right? We are familiar with if else, maybe if else, if someone knows Python a lot. But did you guys know that you could add an else statement to, let's say, a for loop, while loop, or even an exception? So you could, use the try except block along with else. The general idea in Python is, in case you're adding an else to a for loop or a while loop, the else gets executed whenever the loop terminates or whenever the initial condition is falsy. Okay. So when is the else condition not executed? When you explicitly break out of a loop. Let's say that there is this loop, for loop or while loop, it won't make a difference right now. But and if you break out of the loop using a break statement, it's fine. But just in case your loop gets terminated naturally, so then you could add an else saying that, yeah, I broke out of the loop. This is particularly useful when, let's say, you are fetching a data from the API asynchronously, like in a while loop infinitely, and suddenly you don't get a response. So you could use that else statement. In the same way, you could also add a else to a try except block. So try basically, like in other programming languages, tries to execute some block of code. In case an error is raised or thrown, it is handled by the catch block in other programming languages. In Python, it is the except block. Okay, but just in case there was no error, you could go to the else block, and then the else block code is executed. Finally, is executed irrespective of if there was an error or not. Right. The third thing that I wanted to tell you is that Python has some a concept of generators as well. So you could either write some simple functions, or you could create a generator. So maybe some of you guys are familiar with generators or generators. Basically, generators and functions do the same thing, but generators, instead of returning a huge value all at once, it returns a value one by one. Like, so it uses the yield keyword in Python. So maybe we could actually try creating a generator of our own. So let's say I create this function, and it's going to be really simple. And instead of returning something, I'm going to yield something. So I would say yield 1. And then I could always, now you guys know that once you return something, you're out of the function, right? But in case of yield, that's not the case. You could have multiple yield statements. That's the actual point of a generator, that you can return different values every time. And now if I try printing the value that I get from gen, so okay. So these are this is actually the object that I get actually. So it actually tells me like where this generator function exists right now. Then there are some double underscore methods. You might be familiar with these double underscore methods in Python as well. If you have worked with classes and objects, then you might know like the init method, or maybe if you have used the Python, so you would write something like if name equals to main, so that underscore underscore. Those are sometimes called the dunder methods, but the concept, yeah. But the idea in Python is, let's say that you create your own classes and you want to implement some high level behavior. Let's say like addition, multiplication. Maybe you want to use the len function. Maybe you want a string representation of your object. In that case, what you could do is you could implement these so-called dunder methods, double underscore methods, or these data models as I call them. And they basically implement some behavior for you. So you could use the underscore underscore add underscore underscore function to use the plus sign for your classes and objects. Like you could create your own polynomials and use the plus operator now. Same for the mul operator, or for asterisk, it's multiplication or mul. Then you could have a string representation using REPR, the representation. So there are these multiple double underscore methods in Python that exist and you could implement it, and you could get some underlying behavior. Then there are there's a concept of decorators in Python as well. Decorators are a higher order functions. Maybe you have seen the syntax, maybe not. If you have worked with, let's say, something like Flask or Sanic in Python, you might have seen it in app.route. But decorators are basically higher order functions that take in a function and return a function as well. And it just makes your code way more simpler than writing or reusing the business logic again and again. So you could create a decorator for that, and decorators basically work on methods. So let's say that there is a method and it does something, but you want something to happen before and after the function gets executed. So and let's say you have multiple functions before and after which some codes needs to get executed. So in that case, you would use a decorator for that, and basically wrap it using a decorator, and you could just use it again and again. The reason it works in Python is because everything in Python, and I mean everything, is a first class object. Because Python being a purely object oriented programming language, even if you check a function and you check its type, it's going to be an object of the function class. So everything in Python is an object, hence it's assignable. It could be passed as an argument, it could be returned as well. And then again, if working with the classes and objects with the object oriented concept in Python, Python knows itself. So you must have used the self, let's say variable or keyword, if you call it, in Python as well. So it's like the first argument you pass whenever you create a method in Python. But did you guys know that self is not actually a keyword? It's just a convention to call it self, which it kind of acts like this keyword, but not really equivalent to this keyword. But the point is that instead of writing self, you could it's a variable name. It's basically an object reference. So internally, how Python works says that it takes this object reference as the first argument. So you could actually name it accordingly. You could even name it anything. And here's a working example. Like this code actually works. If you create an object of this code, it would work, because instead of writing self, you could call it this, and it's gonna work. It's gonna work just fine. It's not a problem. So this is not just again a keyword. It's just an object reference, just a variable. Yeah, that was some of the concepts that I wanted to cover, or some concepts that really known concepts that I wanted to cover. And this is basically my first FLS. I hope I was I tried my best to give it. So yeah, thanks.